All right, so composite functions are the way to join two functions, and we'll make up two functions. Let's call it fx is x squared and gx, which is x plus 2. Could be anything, could be quadratic, cubic, whatever, x plus 2. So we've got a quadratic function here, quadratic, and this is linear. Okay, it doesn't matter whether they're both quadratic or both linear, we can still do composites. Now, imagine I write the function like this, f g x. Do you think you know what's going on here? Without reading the sheet, do you think you know what I'm going to do next? What do you think I'm going to do here, anyone? Any idea what I'm going to do? Can you see the gx is here? Yeah. And this is gx, x plus 2. So what I'm going to do is put the gx, the g function, inside the f function here. So that would be written as x plus 2 squared. Do you see what I did there? I took my g function, which is x plus 2, and I put it inside my f function here. Because that's actually fx, isn't it? You see what I'm doing? I'm taking my gx function, my g function, and putting it inside my f function here. So that's one example. Now I can do it the other way around. I could do g f x. Do you see what I'm going to do now? I'm going to take my f function, which is x squared. Let's write that again. So I'm going to take my f function, which is here, and I'm going to insert it into my g function wherever I see x. So all I do, I replace the x. So that would become x squared plus 2. Okay, so this is the way we do it. I'll make another example. If you want to copy that, you can copy that down. So here's another example. Fx equals x plus 2. Gx equals 2x squared plus 3x. Okay, any two function. The first one's linear. The second one's quadratic again. So f g x would be what? So you see how I'm putting the g function into, so put g into f. So take your g function, which is this one, and put it into the f function. So you take your g function and you put it into there, wherever you see x. Okay, so that's going to give you 2x squared plus 3x plus 2 on the end, this here. You'll get that answer. Okay, and if you do it the other way around, if you do gfx, so you see how I put it inside the g function. So you're going to put f, which is this function, into g. So let's get rid of the green and that. So now I'm putting the g function, which is x plus 2, and I'm going to put that inside the g function. And you need to put it everywhere where you see x. So you've got to replace that x and also this x here. So what are you going to have? You're going to have 2 x plus 2 squared, right? So we just replace the x in g, and then x plus 2 into here. So you'll have plus 3 x plus 2. like that. This actually has lots of good applications, which I'll show you later. And then you'll understand why we need things like this. Okay, is that one all right? And then you could expand that and simplify if you want to. Probably I'll ask you to simplify in the quiz or in the homework sheet. Okay, so you'll expand out your quadratic and so on. So that's how you do composite. What I did here, I've actually done the same thing. So think about this function machine. So we take an x, right? Let's do the g function first. And the g function is telling you what I want to do to the number. So if you take a number, let's just call it x, and you put in the g function, and it's telling you to double and then add 3. So you double x here, and then you add 3, and you'll get a new number come out. So this is your input 1, okay? And then you'll get an output here, output 1. But your output now becomes a new input for the new function. I hope that makes sense. So you put a number in, you'll get a number coming out, take that new number and stick in the new function. So in this case, it's 2x plus 3. That's your new input. So this is input 2. So that's your new input. And then this is telling you what to do to the number. I raised the number to power 4. So that's actually written down here. This is your f function. So whatever you got from here, you'll raise that to power 4 here. So this will be your output 2. Output number 2. So if we do that with a number, let's see what happens when we use numbers. Okay. What this is really showing is what I've just showed you about 5 minutes ago here. So what if x is 2? So G2 would be 7, yeah? So you put 2 in, you double it, and you add 3. You'll get the new number coming out, which is 7, yes? So then this number goes into your new function. So put 7 in here, and it's telling you to raise that to power 4. So you'll end up with 7 power 4. Okay, and that's basically how it's working. You don't have to remember how to do this on the test though, but the basic idea, you should learn how to do it. Okay, so you can do it the same. We don't need to do that now because we're out of time a little bit. So let's look at examples. Go to example 18. Now this notation is the same as FGX, okay? So this is the same notation. This looks like fog. So basically it's telling you to put G into F from the front to the back, okay? Now, again, this is your notation for function. I don't like it, so I'm going to change it to Fx, which is 3x minus 1, okay? And then Gx, which is 2 minus 5x. Okay, so the first one, it's all written here, so you don't need to copy this. I'll just explain. So we want to do Fg for function, for the variable x. So this is telling you to put the g function inside the f function. This is how we're joining the functions, okay? So we're taking the g function, which is here, and we're sticking that in the f function. So that needs to replace the x here, not anywhere else. You replace the x values of that function. So you're going to end up with 2 minus 5x will be better. 2 minus 5x minus 1. So you see how the g function, which is here, is going inside the f function here. So that's a new function, isn't it? That's a completely new graph if you want to graph it. So 6 minus 15x minus 1. So that's 5 minus 15x there, which is there. Okay. So when you want to do the opposite, so I don't need to copy anything, it's all here. I just need the functions. So let's write g again. There it is. So f is, so I'll just rework the question here. So f is 3x minus 1. Yeah. fx 3x minus 1. Gx is 2 minus 5x. All right. But every question is done the same way. They're all done the same way using this method. So in this case, we want to find GOF. So we're putting f inside G now. So GOFX. So take your G function, the one on the right side, and put it into this function here. So your G function is, your f function is 3x minus 1. We need to put that into G. So that will basically just go in there. So you have 2 minus 5, 3x minus 1. So this is like your first input, putting it into the next function there. 2 minus 5 3 is 15x plus 5, 7 minus 15x here. Okay, like that. Now, the other one that you're going to see is when you have f power 2. It looks like power 2, doesn't it? It's not. So this is one thing to be careful of. So if you see f2x, it is not fx times fx. It is not that. So don't square that function. So it's not this. What it means is that you're putting f inside itself. So you're doing fx, which is okay. There's no reason why you can't do that. So, which is FOF, okay. Like that. So we're putting f into itself, and fx was 3x minus 1, right? So we're putting this function back into itself, which is kind of weird, isn't it? So we're going to take the function, which is 3x minus 1, and we put it back into itself here. Does that make sense? 3x minus 1 minus 1. You see what I did? I put the 3x minus 1, which is fx, and I put it back into itself. Okay, so that would become 9x minus 3 minus 1, 9x minus 4. Okay, here. And the same for g. So we take the g function. Let's just look at that here. We take the g function and we put it back into itself. And you can see how we've done that. 2 minus 5x, 2 minus 5x. That was the x originally there. And then you just simplify to that, okay? Are you getting it now? Any problem? Okay, these are a bunch of examples. So I don't need to do this one. It's done the same way. So you get f, put f into g. Okay, so put the f function into the g function. here. So we get this and simplify. Take the g function, put it into the f function. So now we would take the g function and then put it into the f function, into here. Okay, and then we'll get this here. And then you simplify again. F2 done the same way, f inside itself. And here it says, find the value of x for which this composite equals 7. Okay, so what was fgx? That was this one here. Okay, so this is fgx. So we're going to get 2x squared minus 1 equals 7, like that. So then we just solve that equation. 2x squared equals 8, x squared equals 4, x will be plus or minus 2. Don't forget there could be a negative 2 here because negative 2 squared is also 4. So you'll get 2 solutions for that, which is written down here. So you can follow these examples yourself. That one, find the values of x which g fx equals gx. You already have these from the question. So g fx was 4x squared plus 4x. Gx is x squared minus 1. And you end up with a quadratic and you just solve it. That's all. So define for the values of x for which this composite will equal gx. Okay, you can look at that yourself a bit. Look at that one. You're probably going to die when you see that, right? 11:30, what's the time? 11:30, 12:30, 12. We finish at 12:20. So I'll get through most of the examples, okay? Now for this one, I'll do this again, partially. I might not write all of this because it takes a while. So take a look at your function, which is 2x on x minus 1. Now this is telling you to put f inside f. So do you see what's happened here? The 2x x minus 1 has been substituted into itself here and here. So 2x x minus 1. So we put the function inside itself. Don't stop here. You won't get all the marks if you leave it like this, because I want you to simplify it. Okay, so in this case, 2 times 2 is 4. You multiply the 2 to the top because that's 2 on 1. Okay, so you get 4x here, x minus 1. In this case, I made a common denominator. You see what I did with the 1 here? I made the 1 x minus 1 on x minus 1, which is 1. I did that because I want to have a common denominator here, x minus 1, x minus 1, and then I can join that fraction together here as x plus 1 on x minus 1. Just do it like you would do fractions, because the top line is 2x minus x minus 1, which is 2x minus x plus 1, which is x plus 1 here. Okay, so then we've got 4 on x. I might show a bit of working for that. So you've got 4 on x. I know your head's hurting already. So is mine. X minus 1 on x plus 1, x minus 1. So how do we get to this? Okay, because you're dividing, let's make that a division, which is x plus 1 on x minus 1, isn't it? So I'll rub that out. So I've just changed the form. But remember, when you're dividing fractions, change that to multiply and flip this fraction over. This is going back to grade 5, grade 4, I think. So 4x, x minus 1. Now you'll see that those two cancel, and you'll get 4x on x plus 1 here. So you will see these in the worksheet that are quite complicated, okay? And F3 is just putting your F2 back into F. So F3 is actually F2, or F power 2, superscript 2, not power 2. So put your F2, which you got here, 4x plus 1, put that back into itself again here and do the same procedure again. Then you'll get this answer here after you simplify. But you can look at that yourself for a while. All those solutions are here. Okay. More examples here. Now, I should show you example 5. We only have about 10 minutes, and your working will be next Monday that you do for this section. Now look at this one. Now you've got a quadratic. The problem is we're putting G. We're given a composite, I should say. We're given a composite, which is x squared minus 6x plus 7. And I want to find my two functions, my original functions that gave me this composite. All right, now what you should do here is complete the square, which we're going to do more in core a bit later. Okay, so I should show you this one because we did this actually in grade 9, remember, when we complete square. So let's do that. X squared minus 6x plus 9. This is your composite. So let's try to complete the square. The way we do that, if you remember, we take the middle number, which is minus 6. We halve that, then we square it. We'll get 9, correct? We'll get 9 here. So we're going to add this special number here. So we've got x squared minus 6x. Let's just check. Oh, we've got a 7, sorry. That's 7. I was going to say something's not right, plus 7. So we add this number back in, this 9 here. I'm going to add this here. Right, so plus 9. But you're adding a number. You're adding a new number into this expression, aren't you? So you've changed it. So you've got to go plus 9 minus 9. And then we add the 7 here. So when you add your special number, 9, make sure you subtract it as well here. Otherwise, your equation changed. So these are still equal, aren't they? 9 minus 9 is 0, right? So now the completed square is here. We can write that as x minus the square root of 9 is 3, all squared. We're going to review this in quadratics more. And that's going to be minus 2. So we actually got this here. So x minus 3 all squared minus 2 is the same as that. It's not different. Okay, but now you can see there are two functions. Do you see your g function? Whoop, let's erase that. Your g function is here. Can you see there's a function inside another function? So your g function is x minus 3. Your f function is x squared minus 2. This represents the x, this bit here. So this is actually x squared minus 2. So that's your f function. That's kind of a hard one, so you should concentrate on this a little bit. Okay, so go back and watch the video because I'm recording it. And think about how you do this completing square method here. And you'll see one in the worksheet, but you'll get practice before then anyway. So we got 10 minutes. There's another example. Okay, example, exercise 6. Can you look here for a minute? I'll start you with the first one because I'll stop here and we'll maybe just do this today and then we'll do more on next week. So when you see your function, you've got two functions, f and g. Okay, so we got two. We need to join them together to make a new composite function. So this is telling you to put the g function into the f function. Don't go the other way. So put g into f. Okay, so write that first. So take note of what you're putting where. I'll clean that out because I want to have fresh. So put the g function, which is here, into the f function, which is here. So take your g function, put it into your f function where you see x, nowhere else. So you replace the x of that function. So FOG, you're going to do the rest yourself. So FOG will be 2, 1 minus x. Okay, that's your g function being put in, and plus 3. So that's going to be 2 minus 2x plus 3, 5 minus 2x, finished. Okay, you do B and C. Can you do them and see what they come up like? Answer key in the back. All right, so that's your answer for that one. Can you copy that? What time do we stop? 12. Let me see my thing. I'll close that. Okay, hold on. Let me just check the schedule. 12:20. So you got 7 minutes. Okay, so let's go back. I'll share again. Hold on. Right there. Okay, so you do B and C. If you've got a bit of time, you can try the other ones. So B, you put F into G. Okay, do the opposite to this. And this one's easy to do because we know F, G already. So for that one, you'll use the result here for this one. And we already know what is the function here. So that means you would take your minus 3 and you'll put that into your function and get an answer. So put that in there. So you'll end up with 5 minus 2 x, and x is minus 3. So you should get 11 for that one, for the last answer. So do B yourself and try to simplify. Okay, do that. If you've done that one, go down to question 2 and try that. I think we'll spend one more period next week because this function book I want to get done fairly quickly. Any questions? All right with this? This one, you do the composite and then you find the domain. That's easy enough to do that one. But for B, if you're still watching, we will put F into G now. So that's going to be 1 minus 2x plus 3. So do the opposite to this one. So we get 1 minus 2x minus 3. 1 minus 3 minus 2 minus 2x, or minus 2x minus 2. So you should get that for your answer there, right? Okay. So do some yourself. The more you do in the online class, the more likely you'll do better in the homework. All right. So that's that one, minus 2 minus 2x. What about these two here? This is quite easy to answer actually, because you just end up with a quadratic. So for question 2, take your g, we got 4 minutes. Take your g function, put it into your f function. So take that, put it into here. So you're going to get 2 minus x all squared. Now this is a quadratic, isn't it? So if you wanted to choose a few numbers, so if x is 0, you're going to get 4. If x is 2, you're going to get 0. If x is 4, you're going to get 4. So it's a quadratic, okay? And quadratics, the domain is all real x. Okay, you can see that looking at this graph. I'm not stopping the graph anywhere, am I? I'm letting it go for as far as it wants to go. Okay, so your domain here is all real x, because the graph is not stopping anywhere and I'm not stopping it. So your domain here, you could write x is a member of minus infinity to infinity, or all real x for that one. So the graph doesn't stop anywhere, okay? And this one, you're going to get the same result for the domain. The graph just looks a bit different, okay, for that one. Okay, so you can try that one yourself. I think we'll stop there anyway, because there's only 2 minutes left. And then from this question, we'll continue. So I'm thinking we can get this done in one more period. And you'll get a worksheet on this. So maybe one period. We'll see how our time goes. I may give you like 5 minutes each question, and then you work on it, and then I'll do the answer. But for this one here, we can do this real quick. X squared, so we're going to put f into g. So that function is going to go in here. So you're going to get 2 minus x squared. And that's a quadratic, so that would be all real x. We know this is going to be true. Especially for linear and quadratic. The domain will usually be all real x for your domain. For your graph, when x is 0, y is 2. So when x is 4, when x is 2, let's say when x is 2, minus 2, x is 2, 2 minus 2. So it's going to be down. It'll be like that somewhere. Okay, it's upside down. We're doing more on quadratics later. So this is obviously all real x. Okay, the graph will go in both directions to infinity. And the range is from 2 down. But I only want the domain, so all real x. Okay, so we'll stop there. And then from Monday, we might do some core. I'm going to send you a new big book in core, and I'll send you today. It's about just indices and things. That's something you didn't do last year that we need to do. Okay, so for function, we'll start from this question here. And remember, your worksheet is due tonight about function. So can you try and finish that? Don't worry if you get some things wrong, I'll make the corrections, but you should show some working so I can sort of see what you're doing, okay? All right, so I'll stop there.